me now. Okay?
Yes po.
Have you get and also your instructional manual? Okay, so this is the next topic. This is a thin wall pressure vessel. Okay, so this is the sign of pressure vessels. Okay, so when you see pressure vessel, okay, these are simply containers having pressurized fluid. Yung fluid po, it can either be a liquid or gas. Okay, so when we say this kind of pressure vessels, what we are to obtain is of course the thickness of the plate to be used. Okay, so it comes with a sheet of metal. Okay, so it's a sheet of metal and then iniro-roll po iyon. Tapos yung pinagtugtungan, okay, i-join lang po using a weld o kaya naman po ay rivet and that would become a cylinder. Okay, so ganun po yung ginagawa natin. So how do we design these pressure vessels? Again, to design is to determine the uh, thickness to be used. Okay, so when we design this vessel, we have to know first, okay, kung ano bang klase ng category siya nagpo-fall. Is it under a thin walled or a thick walled? Okay, so pag sabi natin thin walled or thick walled, it does not vary only on the thickness. Okay, so hindi lang po yung thickness yung category natin para doon sa vessel na iyon. Okay, it should be the limiting criteria. Okay, so we have this limiting criteria T over D. Okay, it should be less than or equal to 0.1 to be called a thin walled vessel. Okay, so yung thin diameter dito, it should be the inside diameter. Okay, so T over D should be less than or equal to 0.1. Otherwise, if it exceeds this value, then that would be a thick walled vessel. Okay, so para lang din po ito na compression. Okay, number under compression, wherein okay, you have there the slenderness ratio, and then from the slenderness ratio, you apply a particular or a specific procedure, okay, na gagamitin. So, ganun din po dito. Designing a thin wall versus a thick wall, so magkaiba din po yung procedure na ipa-follow po natin. Okay, so, yeah. So, this would be the first step that you should do whenever you design the vessel. Okay, so you start with the limiting criteria, T over T sub I. Okay, again, it should be within this range, less than or equal to 0.1 to be called a thin wall. So basically, ano po ba yung difference, okay, yung dalawa, okay, ng thin wall tsaka yung thick wall vessel in relation to the stress. Okay, so you look at this illustration po. Okay, so this is yung cylinder tapos kinat po natin. Okay, so you see here now yung area. Okay, this is yung inside wall ng atin na cylinder tapos ito po this would be the outside wall. Okay, if you are to compare the stresses, okay, doon sa loob at saka po dito sa labas, if it is a thin walled vessel, it is assumed to be constant or uniform. Kumbaga, parehas lang po yung value ng dalawa. Okay, yung stress din sa loob at saka doon sa labas. But then, if it is a thick-walled vessel, malaki po yung pagkakaiba. Okay? Alin po kaya yung mas mataas yung stress? Is it dito sa loob o doon sa labas? Anyone? Anyone po? Hello? Hello? Oh, Jean.
Pa-repeat na question pa.
Yes, okay. So you have here, okay, so pag sinabi po natin na thin wall, the stress on the inside walls, okay, of the container or the vessel, the same lang din yun sa walls o yung stress doon sa outside wall. Okay, yun po ay kapag siya ay thin walled. Okay, what if po kapag siya ay thick walled? Okay, so that greatly varies. Okay, so magkaiba po yung value dito sa loob at saka doon sa labas. Ang question ko ay, saan po kaya mas malaki ang value ng atin na stress? Nakuha po ba? Nasundan po ba? Hello?
Sa inside po.
Okay, correct. Okay, so tama po yung sagot niyo. It would be on the inside, which is more exposed doon sa pressurized fluid. Okay, mas mataas po yung stress niya doon. Okay, pero sa thin wall po, it is assumed to be the same. Okay, now, how do we design this pressure vessels? Again, Sabi ko nga po, ang una nating titingnan would be the limiting criteria. Okay? To know whether the vessel is thin-walled or thick-walled. Okay? So once it's, you know it's thin-walled, okay, ano po yung gagawin natin to design the member? Okay? To determine the thickness of the plate to be used. So here, okay, ito pong dalawa na ito are the two induced stresses on the cylinder. Okay, so this one po is your circumferential stress, and then this one is the longitudinal stress. Okay, so you imagine here yung cylinder natin, and then you cut it crosswise, kapag ganyan po, along the circumference. Okay, so yung circumference po yung kinat natin, so you come up with the exposed area. So the stress here po, okay, is measured using this equation, PD over Pt. Okay, P is the pressure, D would be the inside diameter, and then T is the thickness. Okay, ito naman pong isa is yung cylinder natin is kinat natin along the length. Okay, and we come up with the stresses here sa portion po na yan, and that would be called the longitudinal stress, PD over 40. Okay, so same nomenclature naman po yung ginamit natin dito. Ano lang po pinagkaiba ng dalawa? This one is divided by 2, and then the other one is divided by 4. So if you are to compare the two, which one is bigger? Is it the circumferential or the longitudinal stress?
Circumferential po.
Okay, correct. Okay, so tama si Cedric. This is the circumferential is the bigger stress. Kasi ito, dinivide mo lang to ng 2. Ito, dinivide mo siya ng 4. Okay, so this is bigger. And this bigger stress, that would be po yung atin na critical stress. And this would be the basis of our design. Okay, so dito natin i-base yung design natin. Kasi siya yung bigger stress. Okay, so how do we design it now? Okay, just like the usual, anong ginagawa natin? For a good design, we equate the design stress to the induced stress of the material. Okay, so the design stress now is equated to the induced stress, and since the circumferential stress is the bigger stress, so dun po natin siya in-equate. Okay, so this circumferential stress is PD over 2T. Okay, and the design stress can be sigma y over factor of safety or sigma u over factor of safety, dependent upon the basis of design. Okay, so pipili lang po ulit tayo. Okay, now, we have what we call po joint efficiency. Okay, so for the joint efficiency, it is yung kung gaano katibay yung pinagtugtungan. So sabi nga po natin kanina, it comes really from a sheet of metal, tapos ini-roll po natin. Parang sheet of metal, tapos ni-roll, tapos dito po, pinagdugtong natin. Okay? So, it can be riveted or it can be welded. Okay? So, pag sinabi po natin welded, i-melt po natin yung yung filler, tapos doon sa pinagtugtungan, siya po yung mag-join po dun sa dalawang ends. Okay? Ito naman pong rivet, it is synonymous po with parang itsura po ng screws. Okay? But then, ang difference nyo sa screw, yung screw, you can have it, pwede mo pong kalasin, tapos pwede ulit na i-engage ulit, okay? Using a screwdriver. So, ito po hindi. Okay? Kumbaga, masisira na din talaga yung rivet pag inalis mo siya. Okay? Wala po ito kasi na thread. Katulad ng sa mga screws. Okay? So, that is how you join. And of course, kung paano mo po siya join, okay, that affects po yung natin, yung efficiency na yon, yung pagkakadugtong. Okay? And this serves also as stress razor. Okay? Kumbaga po kung masisira siya, pwede siya doon una bumuka. Okay? Now, so if may dugtong po na ganun and the efficiency is not 100%, you have to count that on your design. Okay? So ano po yung gagawin natin? We have to lower the design stress. Okay? So you need to lower the design stress to take care of the weakening of the joints. Okay? So instead of using sigma D, ang ginagamit po natin is sigma D prime. Okay? So ito po yung gagamitin natin ngayon as the design stress. Okay? Aside sigma D prime or the lower design stress. So how do you lower the design stress? You multiply the design stress by the joint efficiency. Okay, so if you are given there 90% joint efficiency, okay, so anong gagawin mo? Anong ating consider? You use simply 0.90. Okay, so you use the decimal equivalent. Okay, so that is to lower your design stress. Okay, and this lower design stress siya po yung equate natin to your induced stress, which is the circumferential PD over 2T. Okay? So, from there, you can now solve for the corresponding thickness of the plate. Okay? So, dun po natin masasolve yung thickness. Okay? Nasundan po ba? Hello?
Yes po.
Hello? Okay, good. Okay? So, yung una po natin nag-discuss, okay, is a thin walled and a cylinder. Okay? So, yung pong ating pressure vessel, commonly, okay, it is in a cylindrical form. So, kumbaga, pumunta tayo sa market, yung makikita natin doon ng mga tanks are mostly po in a form of a cylinder. Okay? So even sa mga planta po, pag nakapunta po tayo doon, what we see on tank farms, okay, yung mga ano natin, are all cylindrical type. Okay? So, mostly po ang ginagamit natin is yung cylindrical type or cylindrical form. But then there are other forms po such as spherical, meron din naman po ng cubical, at saka po yung rectangular parallelepiped. Okay? But then, madalang po yung mga ganon. If you insist on using those forms po, you need to fabricate. Okay? Pero what is really available are those cylindrical ones. Okay? Now, yung sphere po, minsan, makikita po natin sa mga uh, industries, they make use of yung spherical. Okay? Lamang po, yung spherical, ginagamit lang yan doon sa konti lang yung mga liquid or yung gas na i-store mo or ilalagay mo. Kumaga, less volume lang po. Okay? Doon po natin siya ginagamit. Why? Kasi hindi po siya pwede natin gamitin so on big volumes. Okay? Kasi kung big volume yan, okay, in order na ma-accommodate yan ng spherical tank, you will need a bigger space. Okay? Or talagang malaking space. Kasi it will cover yung yung entire area ng atin na tangke. Okay? To increase po kasi yung volume ng spherical tank, okay, ano lang po ang i-increase natin? It would be the diameter. Okay, di ba? Increase mo yung diameter, okay? So, mag increase yung volume ng atin na tank. But then, pag in-increase mo yun, it will take a lot of space. Okay? So, hindi po ideal yun kasi napakalaking space ang gagamitin mo kung malaking volume ng fluid ang iyong ilalagay dyan sa pressure vessel na yan, na gano'n na klase. Not unlike po if it is cylindrical, okay? So kapag cylindrical, okay, dalawa po yung way natin para mapalaki yung volume. Okay? Kasi so equation po ng volume ng cylindrical vessel, okay? Ano po iyan? Sa cylinder kasi, it involves the diameter, okay, of the tank and also the height. Okay? So, diameter tsaka sa height. So, ibig sabihin, pwede nating i-maintain yung diameter at yung height lang ang atin na increase para ma-increase din yung volume. Okay? So, in that way, maliit pa rin na space ang kanya na i-accommodate kasi pataas lang yung ginawa natin. So, when it comes to the land area or the space it would occupy, so maliit pa rin po. Okay? Kaya kalimitan po talaga ginagamit dito sa vessels na to is yung cylindrical type. Okay? Now, so let me go back to this. Okay? So if it is a it is a spherical type. So you imagine yung halimbawa yung bola. So, ikat mo po horizontal, vertical, parehas lang yung lalabas. Okay? So, therefore, we say the longitudinal stress, okay, is also equal to your circumferential stress. Okay? Not unlike do sa cylindrical, magkaiba. Okay? Magkaiba. Dito, longitudinal and circumferential, parehas. PD over 40. Okay? Yung kanina, okay, it's PD over 2T and PD over 40. And the bigger stress is yung sa circumferential. So, dito parehas po. Okay? Having the equation PD over 40. So, same nomenclatures po. P for pressure, D is inside diameter, T would be the thickness. Okay? And what you will do is again to equate this to your design stress. Okay? Which can be based on the ultimate strength or based on the yield strength. Okay? So, nagkaiba lang po dun sa atin na induced stress. Okay? Yung sa cylindrical kanina is PD over 2T. This time po, if it's spherical, it's PD over 4T. And just the same po, if you are given a joint efficiency, instead of the design stress, okay, ang gagamitin po natin would be the lower design stress. Okay? So to lower the design stress, you multiply it by the joint efficiency to be equated to your induced stress. Okay? So, iyan po. Okay? Question? Question? Hello?
Wala pa
Wala
naman.
naman. Okay? So, that is how you design, okay, yung pong atin na thin-walled pressure vessel. Okay? You simply equate the design stress to the induced stress of the material. Okay? Now, what if naman po, we have a thick-walled vessel? Okay? So, for a thick-walled vessel, this time, the limiting criteria T over D sub I is greater than 0.1. Okay? So, it would be a thick wall naman. Okay? So, kapag thick wall, sabi ko nga po kanina, okay, yung stress po niya, okay, doon sa inside wall at yung outside wall, malaki yung pinagkaiba. Okay? And mas mataas po yung nandoon sa directly in contact with the pressurized fluid. Okay? So, how do you design this kind of vessel? Okay? So, we will be using here now what we call the Lens equation. Okay? Or the Lens formula. This is derived from the assumptions that yung ating thick wall or yung thick shell natin, dinivide natin into a series of thin shells. Okay? So, from that po, na-derive ngayon yung Lens formula or Lens equation. Okay? So, listed here are the three, okay, of the Lens equation. One is hoop stress on the inner fiber. Okay? So, ito po yung nasa inside wall. Hoop stress on the outer fiber. And then the last one would be the longitudinal stress. Correction po, pakipalitan lang po ito. This should be sigma and then subscript L. Okay? Ulit, palitan po are. It should be sigma and then subscript should be L. Okay? Yung isa would be sigma T sub I. Okay? Hoop stress on the inner fiber. And this one is hoop stress on the outer fiber. Okay? So you look at those equations, okay, it involves the following components. You have their PI, RI, RO, PO, and RO. Okay? PI is inside a pressure. Okay? So yung inside pressure, kung ano po yung pressure ng fluid natin sa loob ng vessel, the same lang po. Okay? RI is inside radius. Okay? R sub O is outside radius. P sub O is outside pressure. Okay? For outside pressure, if this is not given, you assume to use po yung atin na atmospheric pressure, standard atmospheric pressure. Okay? Pag hindi po given yung P sub O, assume to use the standard atmospheric pressure, which is equal to 14.7 psi or 101.325 kilopascal. Okay? So kung hindi po given, yun po ang gagamitin nating value for this P sub I. Okay? So lahat po ito, yung Lens equation po, okay? Lahat po yon yung function. Okay? Nung na ito po yung mga components niya. Pare-parehas lang po. And you have here lang po yung T as the thickness. Okay? Thickness. Now, sabi ko nga po sa design ng pressure vessel, what we are to determine is the thickness of the plate to be used. Okay? So to determine the thickness of the plate to be used, you use this equations. Okay? So if it's a brittle material, you use this equation po. Okay? If it's a ductile material, ito naman po yung atin na gagamitin. Okay? Look at the equation that involves D sub I, the inside diameter, PI, inside pressure, and your sigma T sub I. So, ibig sabihin po, before you can compute for the thickness of the plate, necessary that you solve first for sigma T sub I. Okay? So, ito muna po ang uunahin natin para po siya yung may substitute natin to any of these two equations. Okay? Dependent upon the type of material. Okay? So, you look at sigma T sub I. Okay? So, this PI, again, probably this would be given. Same thing with your RI. So, from the given inside diameter, you simply divide it by 2. That results to your RI. Okay? And then R sub O is outside radius, and P sub O, if not given, assume to use the standard atmospheric pressure. Okay? But then yung RO po natin, RO will not be given. Okay? This will come from the outside diameter. But then definitely this would not be given. Why? Kasi kung given po yung RO, hindi mo na po kailangan pumunta pa sa equation na to ng thickness. Okay, di ba? Pag sinabi nating RO, it is simply equal to Ri plus yung thickness. Okay? So right away, you can solve for thickness here. RO minus Ri. Okay? So definitely, hindi po ibibigay yung R sub O. Okay? So ano po ang gagawin natin? Okay? Yung R sub O po, papalitan po natin yan ng Ri plus T. Since given po yung Ri, okay, yung T lang po yung atin na unknown. So therefore, your sigma T sub I, pag sinubstitute nyo po dito yung mga values, it would be in terms of the thickness. Okay? So matitira po na equation dito sa value niya, yung thickness. So kasama po yung parameter or variable T. Okay? And yun po yung isa-substitute natin dito sa sigma T sub I, okay, on the equation to obtain the thickness of the plate. Naliwanag po ba tayo doon? Hello?
Opo, ma'am.
Yes po.
Nakuha po ba? Okay. So, ito pong procedure na ito, again, okay, your Lenz's equation or your Lenz's formula, this would be used kapag po siya ay thick-walled pressure vessel. Okay? So, again, we have two ways po, okay, para po i-design yung member, okay? Kailangan lang malaman muna natin whether it is thin-walled or thick-walled. Okay? Now, sabi nga po natin, when we will design the member, okay, what we are after is the thickness of the plate to be used, okay? We are after the thickness of the plate. So, bago po natin malaman, okay, yung procedure, we need to know the type, okay, of the pressure vessel, whether thin-walled or thick-walled. So, we always start with our limiting criteria. But then take note that our limiting criteria is T over D sub I, okay, wherein it involves also your thickness, okay, which is of course the requirement or the unknown. Okay, so ibig sabihin, initially, kung ang pinapahanap po sa atin is yung thickness, we cannot proceed on this limiting criteria kasi kasama po siya dito. Okay? So ano po ang gagawin natin? Okay, if this is the unknown, and this is also the way to start yung solving for the problem. So ano po ang gagawin natin kapag kaganoon? Hello? So ano po ang gagawin natin kapag kaganoon?
Siyempre muna po siguro.
Okay, so tama. We will be assuming again. Okay, katulad po ng sa compression, mag-a-assume din po tayo. Okay? So ano naman po ang assumption dito? You simply assume thin-walled. Okay? You assume thin-walled. Do not assume for a thickness. Okay? Hindi po. You simply assume thin-walled. Okay? So assume thin-walled, then you solve based po dito sa thin-walled. Pag may answer na po tayo base sa thin-walled, tsaka po natin ibabalik to this limiting criteria. Okay? Isa-substitute po natin dito yung naging sagot natin. And if it falls under this range, so ibig sabihin, thin-walled talaga siya. And you can use that value. Okay? So your conclusion is to use yung thickness na na-solve nyo. Okay? Kung hindi naman po, okay, you assume thin-walled first, you solve, tapos you check by substituting here yung answer mo, and it turned out it is greater than 0.1. So you conclude now it's a thick wall, then you need to recompute. Okay? Using yung ating Lenz's equation or the Lenz's formula. Naintindihan po?
Yes po.
Opo, ma'am.
Okay. Okay. So here, yung kasunod po natin are sample problems. Okay? So I'll leave this to you po for your for your computation. But then I'll explain it first po, and then I'll have po yung link Pasa ko po sa inyo yung link para dun sa Jamboard natin where you can paste your answer. Okay? But then, let me explain this first and how you can solve the problem. Okay, first one. Sample problem 1. You determine the bursting steam pressure of a steel shell with diameter of 10 inches and made of 1/4 thick steel plate. Joint efficiency is at 70% and the tensile strength is 60 KSI. Okay? So this is steel shell, meaning this is a spherical vessel. Okay? You are given the diameter here. This is the inside diameter. And this one is the thickness of the steel plate. Okay? So you are given the diameter and the thickness of the plate. Therefore, you can solve for the limiting criteria. Okay? So you start with it. You compute for the limiting criteria, okay? And kung makita mo po kung anong type siya, whether thin walled or thick walled, then you proceed to the equation to be used, your proper equation to be used. There is a joint efficiency here of 70%. So you have to incorporate this on your design stress, okay? This is tensile strength. This is your sigma U. Okay, this is sigma U. Again, 70% would be the joint efficiency. So you have to determine now the design stress. And since you are given joint efficiency, you will be using the lower design stress. Okay? You use the lower design stress. Now, for the design stress, here, you will not incorporate the factor of safety. Diba? Ating design stress is sigma U over factor of safety. Okay? And then multiply by the joint efficiency to lower the design stress. But then here, on this type of problem, you will not be using a factor of safety. Okay, bakit po hindi natin gagamitin ang factor of safety sa design stress? Your design stress will simply be equal to the tensile strength multiplied by the joint efficiency para magkaroon tayo ng lower design stress. Okay? Notice that we do not include the factor of safety. Why? Kasi ang pinapahanap ko sa atin is the bursting steam pressure. Okay? So, ito po yung pressure kung saan posibleng sumabog yung ating vessel. Okay? So, pag nilagyan mo po yan ang factor of safety, of course, hindi po yan sasabog. Okay? Kaya ang sinasabi dito is the bursting steam pressure. So, you do not include here the factor of safety. Okay? So, yun naman po ay dinilaan sa particular problem na ito. Okay? Naintindihan po ba kung paano gagawin? Hello? Nakuha po ba?
Opo, ma'am.
Okay, the others.
Yes po.
The others po. Okay, good.
Yes po, ma'am.
Now, for number 2 naman po, okay, you determine the safe wall thickness of a 30 inches steel tank with internal pressure of 7.82 megapascal. Yield stress of the material is 275.48 megapascal. Factor of safety to use is 2. Okay? So this time naman po, you use here a cylindrical vessel. Okay? So you are given here the pressure in megapascal, so as sigma y, the yield stress. Okay? Now, you solve this sample to po in unit na SI. So you need to convert this 30 inches into millimeter. Okay? Your final answer, the thickness to be used should be in millimeter. Okay? So you have to convert this po and then everything else naman po is in SI. Okay? So how will you solve this now? You look for the thickness. So this time po, hindi mo magagamit initially yung limiting criteria kasi in thickness is unknown. Okay? So you start with your assumption, assume thin wall. Okay? And then you solve using yung procedure para sa thin wall. And then once you have your answer na po, ibabalik mo po to your limiting criteria. Okay? Ibabalik po to the limiting criteria to check if it conforms doon sa thin wall talaga. Okay? Na ratio. Okay? So, yun po ang titingnan natin. Pag hindi po siya na-confirm doon, you need to recompute using the Lame's equation. Okay? Huwag lang po natin kakalimutan, you are to find here the thickness again in SI. Okay? So, you need to convert your answer po in the standard size. Okay? Nakuha? Naintindihan? Hello?
Opo, ma'am.
Hello? Okay. So, you write your answer po on the space provided. Okay? So, and then, I'll send po to you the link of our, Jamboard. Kindly paste po yung inyo na solution doon for our discussion after po nyo na magawa. Okay? So, I'll stop po itong presentation na ito. Okay? And then, I'll show to you yung Jamboard para dun i-paste. You have here naman po yung copy nito dyan sa atin na manual. Okay? Okay, so you may start po. Okay, you may start solving po an hour manual. And then later, if you're done, we can have it po posted dito sa atin na Jamboard. Okay? So, I'll share to you po link ng ating Jamboard dito sa atin na chat box.
Hindi ka na kailangan pang ano.
Okay, share to you is the link of the Jamboard. Okay? Okay, so kindly paste your answers po dito. Once you're done, paki-indicate na lang din po yung name. Okay, so I expect everybody to paste your work dito po. Okay, sige po. I'll give you time first to solve for it. Okay, so alalahanin lang po yung sinabi ko kanina on how you will be solving it. Okay po? Nakuha po ba? Naintindihan po ba yung sinabi ko?
Opo, ma'am.
Okay, good.
Ma'am, excuse po, may tanong lang
Yes
po.
po. Yes po.
Yung doon po sa 1/4 thick steel plate sa number 1 po, 1/4
Ah.
inch po ba yun? Or
Wait lang. Tay, balikan ko ha. Check ko yung copy. That would be in inches. Okay. 1/4 inch. So, 0.25 inch.
okay po, thank you po.
Okay, okay. Cedric? Hello?
Pa?
Cedric? You include here, you have to include here the joint efficiency.
Ay. Sige
The
pa.
design stress, okay, to be multiplied by the joint efficiency. So you have to lower the design stress, okay?
Sige pa, ma'am.
The others. Case din po yung inyong ginawa dito.
Ma'am, spear nga po yung 1 po. Ano po?
Ana?
Spear po
Yes.
ang sa 1. Thank you po.
You use their PD over 40. Okay.
Ma'am, thank you.
Renz? Renz? Hello? Renz?
Hello po, ma'am.
Okay. For number 2, kindly express your answer in millimeters. Okay?
Thank you po.
Okay.
Chika community.
Pinagdadasal ko na matapos mo siya. Mag-support ako.
Mas mahirap pa naman pag ano no.
So, magwalwal na lang kaya.
Hindi pa tayo. Maganda po. Maganda yung mag-iipag.
Ibabaw lang ang meron. Wala ko itatawa na lang. Wala kang
Nasa po yung sa iba.
Ibabaw na lang yung fruit cocktail.
Okay? So, another, may ano lang pala ko na add sinakadito. Okay, eto, kay John. Okay, John Dave. Okay? So, here, your final answer. Thickness is 21.63 mm. Okay? You have to convert this to the standard size. Okay? So, you use the standard size 22 mm. Hello?
Okay po, ma'am.
John, okay. So, for the others, okay, you do the same po. Again, pag lagi po dimension yung hinahanap natin, okay, requirement is the dimension, whether it's thickness, diameter, length, width, height, okay, yan. Ang lagi po natin gagawin is to convert our answer to the standard size, okay? If it is an English unit, ang gagamitin po natin yung nasa atin na design table, okay, yung preferred sizes. Pag siya naman po is ATSI, ang gagawin lang po natin is to convert that to the next higher, okay, na millimeter. So, tama po yung sagot nila, okay? So, pressure is 4.2 KSI, okay? And then the other one naman po, okay, is thickness is 22 mm, okay?
Ma'am, tanong po, paano po kung sa exam yung parang ganito, parehas given? Ano po susundin?
Anak. Okay, so ganito po. So ito po, may mistake lang po ako dito sa atin na manual. Okay? So here po is an error yung na napagsama dito yung English at saka yung SI. Okay? But then definitely dapat isa lang po yan. So if given is in English unit, okay, then therefore yung answer mo should be in English unit. Okay? Kung SI po yung given, ang gagawin po natin, our final answer should be in SI also. So we need to convert yung sigma U and sigma Y taken from our design table to megapascal or kilopascal. Okay? Yun po yung i-convert natin. Okay? Naintindihan na, Cedric? Okay.
Libre sa lahat. May token pa kayo pagkatapos.
Ang ganda na si stop ko.
Hawak ko buong ang pamilya ko.
Yung iba po, pag sagot nyo po dito, nakuha po ba yung answers? So you try to
Yes po,
solve
ma'am.
on your own po para during examination, di makakasagot din po kayo. If you simply listen and then copy or take a screenshot ng mga sinosolve po dito, hindi po yan matututunan. Okay? So you have to solve it on your own po. Now, so next week po would be our midterm exam. Okay? So the midterm exam po, it's scheduled yung sa klase po natin, yung design one, it would be on Thursday. Okay, Thursday, I think it's 9:15 up to 11:15. Okay, so 2 hours. So coverage, just check na lang po kung ano yung atin na room assignment. I do not know if it is dito sa room or doon po sa gym. I do not know, parang, yes, J-Lo?
Ma'am, sa Thursday ko na din lang po sa inyo ibibigay po yung ano, yung design work po namin and yung
Yeah,
attendance po.
yeah. So, the design work number 1 would be due, okay, doon din sa ating exam, okay? So, before 9 o'clock, okay, ano na lang, before 9 o'clock, paki-submit mo sa akin, J-Lo, okay? So, ikuhanin mo na sila lahat, tapos, before 9, ipasa mo na lang sa akin, okay?
Okay po, ma'am.
So, again, so you simply check po yung room assignment or kung gym ba yung gagamitin natin during the exam. Okay? So, again, we will be using our design tables. So, make sure wala pong nakasingit yan, walang sulat yan. Okay? Otherwise, hindi po tayo paggagamitin ng mga design tables natin pag meron po diyang nakasulat na kung ano man. Okay? The coverage would be our members under simple stresses, pure tension, pure compression, pure bending, and pure torsion. Okay? I do not know if this would be not sure pa po if kasama itong atin na pressure vessels, design of pressure vessels, since I will be asking pa po doon sa dalawang section kung makakapag-makeup class kami due to yung accreditation last Monday to Wednesday, I was not able to meet them also. Just like yung isang meeting natin na hindi ko kayo na-meet. Okay, we are at the accreditation. Okay, so if in case na makahabol sila, then we'll pursue with this. So I'll let you know naman po. Okay, before the weekends. Okay, yan. And what else? Okay, so kindly review po machine design terms. Okay, as I have said during our orientation, lagi po yan na kasama. Okay, so take initiative to be those reviewers, okay, on design terms. Okay, so part of the examination, may doon sa objective part po, may kasama po tayo na design. Okay? May question po ba kayo? I am looking at yung submissions ng iba pertaining to the sample problems. Saan po yung inyong na mga sinolve? Napakasimple lang po niyan na i-solve. So, we are po dito, okay? This is 36 minus 2, including me and the presentation. So, 34. So, I am expecting 34 answers here. Nasaan po kaya yung iba? Wala na po ata sa meet natin. Nasa lumian na po ata.
So, abot pa ng 5 p.m.
Yes, Chester.
Ma'am, magtatanong lang po about po dun sa design work, sa number 2 po. Sa letter B po, yung choose steel that would be suitable for the basis of builds. Tapos, paano po kaya
So, you have to compute for the property noong pong steel. Okay, yung property. You are to look for sigma U or sigma Y. And then, you look at the table, saan siya malapit. Then, you simply provide their candidate materials base sa nakuha mong sigma U or sigma Y value. Nakuha mo ba, Jester? Naintindihan mo?
Yes po. Kahit assume lang po ng isang material na malapit po.
You do not assume, but you solve first, okay? Using the given, you solve for sigma U or sigma Y, okay? Parang yun yung unknown, okay? Yung unknown is the sigma U and the sigma Y value, okay? So, base ngayon doon sa naging answer mo, tsaka ka pupunta doon sa table. Alin yung may malapit na sigma U doon or sigma Y value doon sa mga listed materials. Okay? Of course, you cannot get an exact value. Okay? Hindi ka makakakuha ng eksaktong ganun. Okay? So, kung saan lang siya malapit. Okay? So, you can list down several materials in there. Okay? Hello?
Okay po, ma'am. Thank you po.
Okay, okay. Any other? May tanong pa po sila. Yan, dumadami na. Okay? So, ano na lang po. Okay? So, i-close ko na rin po itong meet natin kung wala na po kayong questions. Yung
Ma'am,
iba
pwede
po,
magtanong?
yes po.
Okay.
Cedric.
Yung sa problem 6 ng design work po, paano po yung flange buckling?
Ano?
Sa number 6 po ng design work, paano po yung flange buckling?
That's just the same as yung buckling failure natin. Hello?
Parang compressing failure pa. Sige po, ma'am. Thank you pa.
Okay. Who else po?
Yung mga po, hindi ko pa nakita yung Gibana.
Another thing pala, kindly review po, share the movement diagram, analytical and semi-graphical method. Okay? So, baka po kasi maiano natin na the method to be used ay implied. Okay? So, para po sigurado, okay, i-review na rin po natin. Okay, so kung wala na po tayong question, I will be ending the meet now, okay? You can still send your answers here po sa atin ng Jamboard, okay? So, I am saving po all our Jamboard para makita kung sino yung nagpa-participate during yung klase po natin, okay? Just include po your name on your web, okay? So, okay na po ba? Hello?
Yes po, ma'am. Thank you.
Okay.
naman po.
Sige po, bye po.
Thank you po, ma'am.
Thank you po, ma'am.
Okay.
Thank you po, ma'am.
I'll be ending the meeting.
Thank you po, ma'am.
Thank you po, ma'am. Thank you.